Elements that exist as gases at 25 degrees in one atmosphere are shown here in the periodic table in blue. Some substances found as gases at 1 atmosphere and 25 degrees are shown in this table. Notice that hydrogen, nitrogen, oxygen, fluorine, and chlorine are diatomic molecules. What are the physical characteristics of gases? Gases assume the volume and shape of their containers. Gases are the most compressible state of matter. Gases will mix evenly and completely when confined to the same container. Gases have much lower densities than solids or liquids. Pressure is the force per unit area. We will use units of pressure most commonly in chemistry as 1 atmosphere, which is equal to 760 millimeters of mercury, or 760 torr. The SI unit is the Pascal, which is a Newton per meter squared. Notice the barometer on the right. It shows a pool of mercury and a column of mercury. This determines the atmospheric pressure by the height of the mercury column. Here's a graphic showing the apparatus for studying the relationship between pressure and volume of a gas. As the pressure increases, the volume decreases. That is known as Boyle's law. Boyle found that the pressure is directly proportional to the reciprocal of the volume. That is, the pressure is inversely proportional to the volume. For two states, 1 and 2, the formula P1 times V1 equals P2 times V2 is very useful. The graphic on the right shows the pressure being plotted as the reciprocal of the volume. It's a straight line. Remember to use Boyle's law. It has to be at constant temperature and constant amount of gas. Here's an example. A sample of chlorine gas occupies a volume of 946 milliliters at a pressure of 726 millimeters of mercury. What is the pressure of the gas in millimeters of mercury if the volume is reduced at constant temperature to 154 milliliters? This is the two-state formula for Boyle's law. P1 V1 equals P2 V2. Let's write down what we know. P1 equals 726 millimeters of mercury. V1 is 946 milliliters. P2 is what we'd like to find out, and V2 is 154. Substituting in the formula, we calculate this to be 4460 millimeters of mercury. Variation of gas volume with temperature at constant pressure is shown here. As the temperature increases, the volume increases. This is known as the law of Charles and Gay-Lussac. Here we see that the volume is directly proportional to the temperature. The temperature must be in Kelvin. To change from Celsius to Kelvin, you simply add 273.15. The two-state formula in this case is V1 over T1 equals V2 over T2. Again, an example. A sample of carbon monoxide gas occupies 3.20 liters at 125 degrees Celsius. At what temperature will the gas occupy a volume of 1.454 liters if the pressure remains constant? V1 over T1 equals V2 over T2. Charles and Gay-Lussac's law. Again, write down the knowns. V1 is 3.20 liters. T1 is 398.15 Kelvin. Remember, the 125 is added to 273.15 to come up with 398.15. V2 is 1.54, and we're solving for T2. Solving for T2, substituting into the formula, it calculates to be 192 Kelvin. Avogadro's law. The volume is proportional to the number of moles. The volume equals a constant times the number of moles. The two-state formula is V1 over N1 equals V2 over N2. You can apply Avogadro's law at constant temperature and constant pressure. Ammonia burns in oxygen to form nitric oxide and water vapor. How many volumes of NO, nitric oxide, are obtained from 1 volume of ammonia at the same temperature and pressure? Here is the balanced equation. 1 mole of ammonia gives 1 mole of nitric oxide. At constant temperature and pressure, 1 volume of ammonia will give you 1 volume of nitric oxide.